Broadcast domains. You know, it's interesting in life. There's two or three different terms that mean the same exact thing. A broadcast domain also does business by another name. In this MicroNugget, we're going to take a look at what a broadcast domain is at layer 2, how it interoperates with a switch or a hub, and we'll also learn its code name that is commonly referred to on the networks today. Let's jump in. Some of the terms that we talk about, like layer 2 VLANs or layer 2 broadcast domains, they get thrown out there so commonly. I wanted to pause in this MicroNugget and focus on exactly what they are and how they operate. So to really understand what a broadcast domain is, we should first of all take a look at what exactly is a layer 2 broadcast. Let's say we have a whole bunch of computers. This is a switch here. It is a hub down here. Let's say we have a whole bunch of computers plugged into a layer 2 switch. Now they call it a layer 2 switch because a switch memorizes the layer 2 hardware address on each device that's burned in from the factory, and the switch can make forwarding decisions based on those layer 2 addresses. Simply put, that means if computer A needs to talk to computer B, the switch is going to forward the frames from here to here and not bother everybody else. Very, 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 very smart. A hub, on the other hand, if we had these salespeople connected to this hub, and this one salesperson, we'll call him salesperson 1, want to talk to salesperson 2, the hub would forward, as the bits came into the hub would send it out to every other port, everybody who's connected. So for traffic from one device to another device, the switch is very, very smart, and the hub is very, very unsmart as they make their forwarding decisions. Because the hub forwards based on just the bits in, bits out, it's considered a layer 1 device. Because a switch makes forwarding decisions based on layer 2 addresses from the OSI model perspective, a switch is often called a layer 2 device. And that's why. So what exactly is a layer 2 broadcast? A layer 2 broadcast is when a device needs to get the attention of everybody. Let me show you exactly a protocol analysis of a layer 2 broadcast. Hey, bring them in. There you go. So here's a layer 2 broadcast, and it's going to a very special layer 2 address, and that layer 2 address is this one right here. It's in hexadecimal, which is a fancy way of saying it's a numbering system that uses base 16 instead of us humans who normally use a base 10 because of our 10 digits most likely. In any event, if we convert this from Fs in hex, in binary it's a bunch of ones. How many ones? It's 48 of them. 48 ones is the destination address for a broadcast. So if a device like this PC right here needs to send a frame or a packet to everybody on the network, what it can do, it can send it out to this special address, which is the broadcast address, and the switch is going to forward that broadcast to every single other port that's currently active on that switch. So if this is a 144 port switch and all ports are full, there's devices connected, one broadcast is going to be sent to 143 other ports. Everybody's going to get it. What would a hub do? Well, here we have an 8-port hub. And if we had 8 devices all connected to this hub, and one device sent in a broadcast frame, the hub, because it forwards the bits to every other port, it would also forward it to all other ports. So if you take a look at a broadcast, a switch is one broadcast domain by default, and so is a hub. So what does it mean to be a broadcast domain? In simple terms, it's how far a broadcast will be forwarded. In a switch, by default, it's all ports. Everybody's going to see the broadcast. On a hub, it's all ports. So in that perspective, a switch and a hub, regarding layer 2 broadcasts, they behave the same. So what is a broadcast domain? It's how far a broadcast will go, but what can we do to reduce the impact? I'll tell you what, if I have 144 devices all connected to this switch, I don't want every single one of them to have to interpret and take a deeper look at a broadcast frame if it's not for them. What we can do is we can carve up our network into smaller chunks. Maybe we take half the ports and we put them in one group, and we take another half, or approximately half, and we put them in another group. Now what do they call this? They call this concept VLANs. So we could have VLAN 2 and VLAN 3, and we could separate them. So now the accounting, for example, we could put all as part of VLAN 2, and the sales we could plug in all as VLAN 3, and now the broadcast domain has just been sliced in half. We have 2 broadcast domains. So when people talk about layer 2 broadcast domains, what they're also talking about is they're also talking about VLANs, virtual local area network. And they're synonymous, meaning you can use one word or the other. We're talking about the exact same thing. See, now in this red VLAN here, a broadcast that's sent in only gets propagated inside of the red ports. Other ports also part of that VLAN. So the VLAN for sales, a broadcast goes in here, only the devices there in that VLAN need to process it. So in this MicroNugget, we've identified what is a layer 2 or what is a broadcast domain. And a broadcast domain at layer 2 is how far a broadcast will go if it's put into a port on the network. On the hub, it goes to every other active port by default. On a switch, it goes to every other active port by default because a broadcast could be news for virtually anybody. We need to propagate it. So the response is the same. And then finally, how do we reduce the impact? We don't want to send a broadcast to everybody. The answer is you create smaller broadcast domains. The name for those broadcast domains are VLANs. So this could be VLAN 3. This could be VLAN 2. I'll note that here as well. And that's how you can lessen the impact. Also, I should point out that usually associated with each VLAN, each layer 2 broadcast domain, we're also going to have a separate layer 3 IP network. You can think of IP networks like street names. So all these people live on maybe street 10.4.0.0, and all the people in this street live on street 10.5.0.0, and that the IP address piece would be configured on the actual computers themselves. So the switch is going to control which ports belong to which broadcast domains or which VLANs, and then the PCs, once they're plugged into those ports, all need to agree on a common street that they can use together to communicate. I hope this has been informative for you, and I'd like to thank you for viewing.